So let's get a start on 19. So 19 says to find the second derivative when x is equal to 2. So the first thing I would do is rewrite this as a 1/2 power. And remember, we're going to have to do the chain rule. So the first derivative takes the 1/2, drops it down in front, leaves that stuff alone. The power drops down by 1, and we're going to multiply by the derivative of the inside, and the inside derivative is 2x. Now, normally I would say, you're good, don't worry, just plug in 2. But because we're going to have to take the second derivative, let's make that just a little prettier. The 1/2 and the 2 cancel out, and we're going to leave it like that. Now, unfortunately, at this point, you might recall that we're going to have to do a product rule because the x is multiplied by something that's kind of stuck. There's no way to really truly multiply it and integrate it into it. So let's now do our second derivative. So I'm going to consider this my first piece and this thing my second. So it is the first times the derivative of the second. So that negative 1/2 drops down. Leave the stuff alone. Power goes down by 1. Multiply by the derivative of the inside. Then plus the second times the derivative of the first. And the derivative of x is just 1. Now remember, we have to plug in 2. So that's going to be 2 times negative 1/2. 2 squared is 4. 4 minus 1 is 3. 2 times 2 is 4. 2 squared is 4. 4 minus 1 is 3. And we're good there. So we're going to get negative 4 over. Now, what is 3 to the 3/2? Now, the 3/2 is the power was negative, so it's just going to go under the 4. Well, that's really 3 times the square root of 3, and that's the way I'm going to write it because I will rationalize it when we're done. Okay, so let's rationalize that. So that's negative 4 square root of 3 over 9 plus square root of 3 over 3. Get a common denominator by multiplying this by 3 on top and bottom. And so we get negative 4 square root of 3's plus 3 square root of 3's is negative 1 square root of 3 over 9. Okay, so that is problem 19. Now let's take a look at 20. So the first thing on the far right side of your screen in red, you'll see that I first would do a rewrite on that problem. And so let's rewrite it like this, and then let's do the derivative. Now remember, the derivative is going to cause a chain rule because we have that stuff stuck inside of the 1/2 power, which was originally a square root. And so the derivative is going to be 1/2. Leave the stuff alone. Power goes down by 1. Multiply by the derivative of the stuff. So the derivative of the stuff inside is going to be 1 plus 1/2 x to the negative 1. Now remember, in this one, we want the first derivative when x equals 1. So let's do that. So all of these x's are going to become 1's. So we get 1/2, 1 plus 1, which is 2. And then we're going to get 1 plus 1/2 times 1, which is just 1 plus 1 half. So all I've done now is do a few little changes. This becomes 1 over the square root of 2. This is 3 halves. So on top we have 3. On the bottom we have 4 square root of 2. Let's rationalize by making that multiplying by square root of 2 on top and bottom. So we get 3 square root of 2 over 8. So there is that one. Hopefully I didn't make any little mistakes along the way. These are easy ones to do that. Anybody have any questions about 19 or 20? Okay, let's move on to 24. Now I like 24 because there is some chain rule stuff, and so it just reminds you how the chain rule worked. And Nick had asked about unit circle stuff, so I had to throw one of those in there. So let's take a look. So our first derivative, the 3 that's here, is going to drop down in front. The stuff is going to stay there, and the power is going to go down by 1. Now, we have to multiply by the derivative of the stuff inside. So if I didn't give you anything else, but I just said, what is the cosine of 2x minus pi, you would do the negative sign of 2x minus pi. But then you would multiply by the derivative of that inside stuff, which gives us an extra little 2 hanging out here on the end. Now that's our derivative at just x. So now we need to plug in the x value they gave us, pi over 6. So 2 times pi over 6 becomes 2 pi over 6, or pi over 3, minus pi is negative 2 pi over 3, because we had 1/3 minus 1 whole is negative 2/3. And the same thing is going to happen here. Well, what in the heck is negative 2 pi over 3? Well, negative 2 pi over 3 is negative 120. And if we do 360 minus 120, that lands us in the 240 spot. So like if we go back and think about the unit circle, that's right here. That is the point, negative 1/2, negative square root of 3 over 2. Okay, so that's going to help us. So the cosine of that is the x value. So that's going to be negative 1/2 squared. And then this is going to be the sine value, the y value, negative square root of 3 over 2. And then we're going to get 3 times 1/4 times square root of 3 over 2 times 2. So we can cancel these 2's out right here if you want to. So on top we're left with 3 square root of 3, and on the bottom we're left with a 4. So there's that one. It's a good old unit circle problem for you.
I have a question.
Sure.
So would the 2 go into the pi over 6, making it pi over 3?
Yes, that's what I did. So what I got in that parenthesis, I got 2 pi over 6, which became pi over 3 minus pi, which became 2 pi, negative 2 pi over 3. So yes, that's exactly where I got negative 2 pi over 3, because I just did this subtraction. Because it's, think about 1 whole off of pi over 3 gives me negative 2 pi over 3. Any other questions about that one? Okay, so the next one I thought would be helpful was 41. So let's take a look at that. And I'm going to cut and paste this to a new sheet just so we have it. We have a little more room here. Okay. So it says a rectangular open tank is to have a square base. So I'm going to make a little, pretend little box. And we know that the bottom is square. Now remember, there's no top as far as materials go. Its volume is set to be 125 cubic yards. The cost for the base is $8. The cost for the sides is $4 per square yard. Find the dimensions in order to minimize the cost of material. So we're minimizing the cost for the surface area. So if we think about the volume is x squared y, and that has to equal 125. And the cost is going to be $8 per square yard for the base. Now the base is an x by x, so it's x squared. The sides, now let's do the sides. This side is x times y. The back is going to be x times y, and there's 4 of those. So it's $4 for 4 xy's. Now, anytime we've done minimization problems, I always tell you one of the key is, and the same thing when we're doing related rates, is we only want one variable showing up in our problem. We have 2 here, but we haven't used the fact that x squared y equals 125. Now the easiest one to solve for, I think, is y. Y is 125 over x squared. So we're going to put that right here so we have an equation with only one variable. So we get 8x squared plus 16x times 125 over x squared. Now remember, to find minimums or maximums, we are using the first derivative. So we know we're going to have to take a derivative of this. And so because of that, let's get it ready. So 16 times 125 is 2,000. But let's make that x to the negative 1, just so that it's ready. Now, we want to minimize that, so let's take the first derivative, which is 16x minus 2,000x to the negative 2. So all I've done is taken just a standard practice first derivative. Now, we would need to know what are the critical numbers for this. So where is 16x minus 2,000 x to the negative 2 equal to 0? Well, I don't like the fact there's a negative 2 there, so let's multiply everything through by x squared so that we can get rid of that. Now, we know x isn't going to be equal to 0, but we're not going to make a box with no dimension, so we can disregard that worrisome problem. And we get 16x cubed minus 2,000 equals 0, which is easy to solve. So how do we solve it? Well, get the 16x cubed by itself, divide by 16. 2,000 divided by 16 is 125. So x is the cubed root of 125, or 5. Okay? Now, go back and read the question. We only got one answer. There's no plus or minus for a cube root. So we can pretty much guarantee that the number we found, 5, is the dimension we're looking for. Now it says find the dimensions of the tank in order to minimize the cost. So we want the x's both to be 5, and then the y has to be 125 divided by 5 squared, which is also 5. Usually if you're dealing with something you're trying to minimize the cost of and there are rectangular or square things involved, you end up getting as close to a cube as possible. And so that is very common. So what are the dimensions? Well, it should be 5 by 5 by 5. So there is just another minimization problem. I think that's a good one. Okay. What did I want to do next? Let's see here. Let's do some more integration. Let's do 58b. 58b. So let me get some paper here. Okay. So if this was a standard polynomial, I could take an antiderivative and be done with it. But unfortunately, it isn't. We have this thing that's trapped. So when you see a thing that's trapped, you should think, oh, that's a chain rule that I have to undo, which makes me use U substitution. Now here's how we know that U substitution is probably going to be our friend. This is a fourth power. Its derivative should be a cube. Oh, I see a cube. This is a first power. Its derivative, the x goes away. Oh, that went away. So it looks as if the derivative of this is living somewhere in the problem. So this tells me what my u is going to be. It's the thing that's trapped. So you're going to let your u be the thing that's trapped. We're going to take the derivative of that, just a standard good old derivative in terms of x. So that's what du dx stands for, the derivative of that in terms of x. Well, what's the derivative? Well, it's just 8x cubed plus 4. Now that doesn't match what's in the problem, but it's super darn close. It's just like I took that and multiplied by 4. Now remember, we want it to get it match all of the junk that's in the problem. So we want this to say 2x cubed plus 1 dx. So here's my idea. Let's factor out the 4 so we can see where the 2x cubed plus 1 is living. Now, let's leave the 2x cubed plus 1 and the dx on one side, because that's what we need to replace in the problem. But the 4 doesn't need to be there. There's no extra little 4 sitting in the problem. So how do we do that? Well, we take and we make it a 1/4 du on the right side. So what do we know? Well, this is equivalent to 1/4 du. This is equivalent to u. So we know the exact substitutions to take out everything from the problem related to x and turn them into u's. So let's do that. So we have the integral of u cubed 1/4. I usually put any constant out in front. You don't have to, but it's helpful. Du. Now, we ignore that this was our problem. Nope, that's not our problem anymore. This is our problem. So it's just an antiderivative. What's an antiderivative of u cubed? Well, that's u to the 4th over 4, or you can put an extra 1/4 out there, plus c. Now, the original had x's in it. Our final answer has to have x's, but we know what u is equal to. U is equal to 2x to the 4th plus 4x. So let's put it back in, and we're done. So we get 2x to the 4th plus 4x to the 4th over 16 plus c. That's it. That is our answer. Any questions about that one? Okay. Last problem we will do is problem 63 about a volume. Okay. It says find the volume of the solid generated by revolving the region you see of y equals x to the 3 halves, the x-axis, and the line x equals 4 about the x-axis. So you need a picture. X equals 3 halves is somewhere between a line and a square function, okay? Now, we want the x-axis and the line x equals 4. So let's just put the line x equals 4. 1, 2, 3, 4. There's the line x equals 4. Vertical line. Okay? Now remember, we're rotating about the x-axis. Now, the graph looks, if you here, let's see, because of the 2 in the bottom, we can only get positives. And I think you can see this right now. But see how it's kind of like between a square root and a line and a square. You know, it's not quite as steep as an x squared. If we think about plugging in 4, 4 to the 3 halves is 2 cubed, or 8. So we're all the way up at 8. Okay, so we're talking about this region here is going to get revolved around the x-axis. Now, it's in terms of x's, so that's really good. Remember, it is going to be pi times your outer radius squared. So we're going to integrate from 0 to 4, pi times our outer radius, which our only radius is that x to the 3 halves squared. Now, you can square that. That is going to be x cubed. And it's just now a standard antiderivative. Just let the pi come along for the ride. And so that's going to be pi x to the 4th over 4 from 0 to 4. Well, if I plug in 4, I get 64 pi. If I plug in 0, I get 0, so the answer is 64 pi. So I did want you to see a volume problem. Any questions about that? Okay. Well, that really covers a lot of the types of things you're going to see on your final exam. Just so you know, these problems, I would go back and do them again, and that will be a good way to prepare for your final.